All right, let's look at number 2 in 9.4. This is one of the tougher problems in 9.4 for many students, um, but it's about the idea of things traveling in opposite directions. And in this problem, they're traveling for the same amount of time. What we have is a westbound and eastbound train that are leaving from a point that they just decided to be Cleveland. So I'm going to say I'm going to use this little table method here. Um, you might do it slightly differently, but this is a nice way to keep your information organized. Now remember that rate times time equals distance here, and so I'm going to fill in the rate here. And since this is what we're looking for in this problem, find the rate of each train, and we want to kind of stick along with module 9 here, I'm going to let these two unknowns be different variables. Now you could do this in one variable, but since we're in module 9, I'm going to show you using two variables, okay? So the time that these two trains travel is both 4 hours, and then we can make this column here by multiplying the rate and time together. So I get 4x here and 4y here, okay? So let's use a little bit more of the information here to see if we can set up some equations here. One thing is I'm going to try to do is set up some type of relationship between the speeds, because they say something about one train is 3 times greater than the other train. So if I think about speed, all right, and I say that the west train miles per hour is equal to the eastbound train miles per hour. We know that's a false statement because it says one of them is 3 times greater. Now it's this one that's greater. The west train is greater. This one is more by 3 times. Now it's common instinct for many students to put the 3 with this x here because it's 3 times greater. But since this side is already greater, we actually have to amplify this side. And so we're going to put the 3 here to be able to use that equality. Okay, that's a little tricky maneuver there, and you'll have to practice it. Next, I'm going to think about the distance here and what we can do with distance. Well, quick little diagram here. You know, if you have a person that walks this way 10 miles, okay, and then you have a person that starts at the same spot and walks this way 7 miles, how far apart are they? Well, they're 17 miles apart because we would add those two distances together because they're walking in opposite directions. So same idea in this train problem. We know that one train's going west and one train's going east. So I'm going to add those two distances together to get the distance apart. And it tells us in the problem they're 648 miles apart. Okay. So hopefully you can see your matrix here. It's a little bit tricky with this because I have to move it over to get it onto the left side. So I get -3. And then that leaves me nothing on the right side of the equation. For my equation 2, I have 4, 4, and 648. Okay. And then I'm going to do a ref on this. I'll get my familiar 1, 0, 0, 1. Okay. And then I find out that I get 126.5, I believe it is, and 40.5. Unfortunately, I wrote so small I have to put my glasses on to read my own notes here, and it's actually 121. Okay, 121.5 and 40.5. Okay, so we have 121.5 miles per hour for the faster train, which is the west train, and we have 40.5 miles per hour for the east train. I just want to mention, be a little careful here with this statement here. If they would happen to say that one train is traveling 3 miles per hour faster, it would have been a little different statement. It would have been y plus 3. So you have to be a little careful with the speed relationship here, and there'll be some more practices in Hawks that you can look at, but hopefully you can get that set up and then use REF to quickly solve your problem. So, all right, good luck with that. I'll move on to problem number 3.